Today, we're going to pull back the curtain on something you probably walk past every day but never really think about. It's the unsung backbone of our entire electrical grid. And believe it or not, its secret is hiding right inside this switch box. When you think about electricity, what comes to mind? Probably those huge power plants, right? Or maybe miles and miles of transmission lines crisscrossing the country. But what if I told you that's not where safe, reliable power really begins?
The answer? Well, it's going to surprise you. It's not in some massive far-off facility. Nope, it's way, way closer. It all starts right inside this box. This kind of boring-looking metal box, the switchgear panel.
Okay, so to really get why this box is such a big deal, we've got to look inside. We need to meet the real hero of our story, the busbar system.
So this is a busbar, and the best way to think about it, it's literally a superhighway for electricity, a simple strip of metal, right? But its job is massive. It takes all that high current power coming into the panel and acts like a traffic cop, directing it safely and efficiently to all the different circuits.
Let's put it all together. You've got power coming in from the grid, hitting that switchgear panel. Then, boom, the busbar takes over. It's the central hub, the distribution center, making sure every bit of that energy gets exactly where it needs to go, to the circuits that power, well, everything. It is the critical link in the entire chain.
But here's the catch. For the longest time, the way we made these absolutely essential parts was, well, it was a problem. A big one. It was all done by hand, and that meant it was full of risk and, you guessed it, inconsistency.
And check this out. This quote really hits home. It says that if a bus bar is poorly made, it's not just inefficient, it's a potential safety hazard. We're talking about a tiny mistake leading to massive consequences, power loss, total system failure, or worse, really dangerous accidents. The stakes are incredibly high.
So you see the picture, right? When you're making these things by hand, you're just asking for trouble. For starters, you get inconsistent results. One piece is never quite like the next. The whole process is painfully slow and takes a ton of manual labor. And think about it. Every single time someone makes a cut, or a punch, or a bend by hand, the chance for human error and those safety risks just skyrockets. So what's the fix? How do you take human error out of the equation? You bring in the machines. You use a precisely engineered, automated solution. And let me tell you, automation is a total game changer. Suddenly, you've got absolute consistency. Every single piece is a perfect clone of the last. You get these huge boosts in efficiency, which is exactly what you need for today's massive energy projects. Plus, it's way safer. You're not asking people to do those high-force repetitive jobs anymore. But the biggest deal of all? The precision. We're talking a level of accuracy that was science fiction before.
Yeah, let's dive into that a little deeper, because this really is a revolution in precision. I mean, we're talking about tolerances so tight they're measured in a fraction of a millimeter. Think about that. Inside today's super complex panels, there is absolutely zero room for error. If a bend is off by just the tiniest bit, the width of a human hair, it can throw the whole system out of whack.
So how is that even possible? Well, it's all thanks to tech like CNC. That stands for Computer Numerical Control. Basically, these are smart machines that follow digital blueprints to the letter. They guide every single cut, punch, and bend with a kind of perfection that, let's be honest, the human hand just can't match. Not even close. And this incredible leap in precision, it isn't just a cool tech spec on a brochure. It has a huge real-world impact on a global scale. We're talking about guaranteeing quality and safety in critical projects everywhere. Just think about the things that power our modern world. Those massive data centers that are basically the internet's home, they need this. Those sprawling solar farms soaking up the sun, they need this. Huge factories, giant office buildings, all of them rely on switchgear panels that have to be made fast, made right, and made to the exact same standard every single time. That's the world these machines unlock. And we can see this in action. Take this case study from payapress.com. It breaks it down perfectly. When their machines have simple, intuitive controls, what does that mean? It means people can learn to use them faster, so production speeds up. When they have flexible tools, they can create custom solutions for tricky, one-of-a-kind projects. And if the machine is built tough, that means less time wasted on maintenance. See, these aren't just features. They're direct, real-world benefits for building our global power grid. So where do we go from here? Well, it's pretty simple. As our power grids get smarter, the machines that build them have to get smarter too. And that future is already starting to happen. We're talking about machines with built-in diagnostics that can actually predict when they need maintenance before they break down. Imagine that. Or how about using AI to help engineers map out the absolute most efficient bus bar layouts? And of course, there's a huge push to make the whole process greener and more energy efficient. The evolution isn't stopping.
It really all comes back to this. Inside that simple metal box is a piece of technology that is anything but simple. The humble bus bar. It's the perfect example of a hidden innovation that our entire world literally depends on. And that really gets you thinking, doesn't it? What other invisible technologies are out there quietly becoming the cornerstones of our future?